Hi all, welcome to week one of BUSS1020. BUSS1020 is the quantitative business analysis course. It is basically the maths, statistics, application of statistics course in our commerce degree. It is a mandatory class. That means all graduates of the Bachelor of Commerce have to complete it. Let me move my camera out a bit. Ooh, that is not what I want you guys. Okay, so a quick introduction about Buzz 1020. So on the USIT website, we can have general information about Buzz 1020, about quantitative business analysis. Right here, well, first of all, we could see the weekly schedules. So of course, as all classes, it has 13 weeks or 12 weeks of material. Starting today in this video with week one. So introduction to data, um, Week 2, numerical descriptive measures. Week 3, basic probability. Week 4, discrete probability distributions. Week 5, continuous probability distributions. Week 6, sampling distributions. Week 7, confidence interval. Week 8, one sample test. Week 9, two sample tests. 10, linear regression. 11, linear regression, part 2. And 12, multiple regression. And 13, which is BD assessments. So from this weekly schedule, you could see this is basic statistics, basic application of statistics, usage in business, in a business environment, and in a quantitative to analyze objects and analyze situations with a quantitative method. The assessments are broken down into these groups. So homework, each week we will have homework contributing to 10% of the grade. In-semester exam, so it is contributed to 20% of the grade. So this is the mid-semester or the midterm exams. Group assessments will contribute 30% of the grade, and the final exam will contribute to 40% of the grade. And if you fail the final exam, you fail this entire course. So, so that is a brief introduction to Buzz 1020. So let's get into week one. Week one's content, which talks about introduction to data. So by the end of this video, you should be able to talk about and to discuss in quite a sound manner how businesses collect and use data, statistics and analytics, some basic vocabulary of statistics and analytics. So this week really was just laying down the foundation for future weeks and the future terminologies and vocabularies that were used, as well as the types and variables and levels of data management. We also are going to be talking about data collection, including types and sources of data used in businesses, the principles of effective data sampling, and lastly, organizing and visualizing data. So the tool of Excel. Oops, that is the wrong document. The tool of Excel is a major tool that we are using in this course, and in the future we are going to be using Excel quite a bit, starting from week 2. All right, so this is introduction to this week. Sure, right. Introduction to business analytics and statistics. So let's look at our notes. Okay, week 1. So business analytics refers to the process by which businesses use statistical methods and technologies for analyzing historical data in order to gain new insight and improve strategic decision making. So big data, a lot of businesses, they really want to improve how they do business, how efficient they are. They want to cut costs and increase profit margins. So what they do is they could look at past data points, and then they can make informed information based on the data. Now, in order to make informed and accurate information, they have to do a business analysis. They have to analyze these statistics. Statistics comes in a lot of forms, but the definition of statistics is a form of mathematical analysis that uses qualified models, representations, and symbols. And all right, I do not remember writing that, but okay, for a given set of experimental data or real life studies. So statistics study methodologies to gather, review, analyze, and draw conclusions from data. So yeah, that's just a brief understanding of statistics. And we talked about one of the objectives of this week is we want to know how to collect data. So we talked about a brief way to understand how to collect data is the COVA framework. Define the parameters and the sort of data you want to collect the data, organize the data, so that's sorting, perhaps getting rid of outliers, visualizing the data, so making sense of the data, and analyzing data, so putting the data into the context of what the question is trying to understand, or what the question is trying to answer. So the three branches of statistics. We have descriptive statistics. So that's the definition. Descriptive statistics. We have predictive statistics, and we have inferential statistics. Now, descriptive statistics is used for collecting, organizing, and presenting or summarizing data. So this is really quite clear. So of how many students that have a 90 and above study more than how many hours on average do students study. So that's descriptive statistics. You collect information based on how many hours a student studies, and then another matrix perhaps on the results of their grades perhaps. Organizing, presenting, and summarizing data. So that would be a method of taking a snapshot of a group of students and then describing this group of students through descriptive statistics. Another thing statistics can do is predictive statistics. Of course, the past doesn't predict the future, but in many cases it does. So to make predictions based on samples of data and a model. So weather patterns, perhaps, or whatnot. We can draw from past trends to predict future events. So that's the whole idea of predictive statistics. Inferential statistics use data collected from a small group to draw conclusions about a larger group. So if we want to know the quality of our oranges that we are producing on our farm, it is impractical and perhaps even impossible to do sample tests of all of the oranges that we produce on a farm, because it will ruin the orange, because we have to slice the orange open in order to do a quality test. However, if we take a sample from the larger group of oranges, we will be able to make an inferential decision based on the small group to make conclusions about the larger group. So that's the idea of inferential statistics. Okay, so these are the three branches of statistics as outlined here. Here's another practice. If you could just like drag it into each of this, whether or not these are descriptive, predictive, or inferential, but this is quite fundamental, quite elementary knowledge. Vocabulary, variables, and levels of measurement. Now this is quite important. So here's some basic variables about statistics. Looking at these, if you took any high school statistics, these are as a variable, data, operation definition. Population is the whole sample, is what you take out of parameter. Parameter is a numerical measure that describes a relevant characteristic of a population, and statistic is the numerical measure that describes the of a sample and whatnot. All right, so this is basic terminology and key points. So here's the key point. Parameters are for populations that are usually denoted by the Greek letters. Statistics are for samples that are usually denoted with Latin letters. So that is the idea of population. Mu versus x bar. Mu will be for the mean of the population, whereas x bar would be the mean of a sample, for example. Population versus sample. So as we talked on the orange example, right? So the orange farm produces a whole batch of perhaps 500 kilograms of oranges. And what happens is that this entire 500 kilograms is a population. If we want to do a quality test on the population, we could take perhaps 1 kilogram out of the 500. It has a little much. 1 kilogram out of the 500 and do a sample test on it. So that is a sample out of the population. All right. In types of variables, we have categorical, which are qualitative, and numerical, which are quantitative. So qualitative has nominal and ordinal, while as numerical has discrete and continuous. Okay. So for example, the number of pets people have is of course numerical. It is quantitative. The number, so that's quantitative, and it is discrete because you cannot have half a pet. On the other hand, categorical will be the names of different shoe brands people are wearing. Now that would be nominal, whereas nominal could also be, whereas other categorical variables could also be ordinal. Okay, so some vocabulary and basic levels of measurement. Um, so we have 4 levels of measurement. Okay, so the 4 levels of measurement goes from the broadest to the most narrowest to the narrowest. So nominal orders of measurement just basically put variables into different categories. So for example, we have growth index funds, we have value index funds, we have momentum index funds. So what we are doing here is we are putting these variables into different groups. So this is what we call nominal measurements. However, if we rank these specific variables into a specific ranking, then we have an ordinal. So this is, for example, if we go on Yelp or on Google Maps, what we will see is we could rank these restaurants. A 5-star is better than a 4-star, which is far better than a 1-star. But the difference, or the marginal difference between a 5-star and a 1-star is not the same. Therefore, that differentiates it from interval, where the difference between 1-star and 2-star is the same as the difference between 5-star and 4-star, for example. Lastly, we have ratio, because for example, temperature is an interval scale. It is an interval measure of data. What temperature does is the difference between 10 degrees Celsius and 11 degrees Celsius is exactly the same as the change in the temperature between 100 and 101 degrees Celsius. However, 0 degrees Celsius does not imply the absence of any temperature. What it implies, however, is just an arbitrary number. Whereas ratio scales, when ratio scales are 0, what that conveys is that there is an absence of heat. So that would perhaps be Kelvin. So these 4 levels of these 4 levels of measurement goes from the least restrictive to the most restrictive. All right, primary data sources. Let's talk about that now. Data collection. So in data collection, we have sourcing data. So data may be sourced from a range of methods, including capturing the data from particular businesses or organizational activities. The number of minutes people spend in a grocery store. So that would be capturing sourcing data. Capturing data compiled by individual activities. Collecting response from a survey. Surveys are a great way to collect data. However, they may often be very biased due to framing errors or due to non-response errors or due to confirmation bias or due to a whole array of different problems. A designed experiment and recorded outcomes, an observational study and recorded in its results. Now, let's do a differentiation between primary and secondary data sources. Primary data sources are where the data analyst collects the data. So this is traditionally using data sourced within a business or organization. For example, an example of this would be sourcing transactional information such as sales data from within the business to help evaluate the success of a particular marketing campaign. Whereas secondary data sources are where someone other than the analyst collects the data. So this could be collected by the business or the organization, or some third parties such as government organizations, international organizations such as the United Nations, or censusing organizations. Okay, so here we have some examples such as structured data. So structured data is when data has perhaps could be put into rows and columns. Structured data traditionally easily accessible, such as stock prices, right? These are really structured data. Unstructured data, on the other hand, needs more interpretation. These data contains irregular patterns and values that are not comprehensible, such as likes, such as retweets, such as emoji reactions. They do not have the same structure or the same organization that structured data does have. Now, of course, when collecting data, especially raw data, there's a lot of errors, there's a lot of outliers perhaps that have to be accounted for. Perhaps there are some true responses in these surveys. That's why data cleaning also has to come into play and ensure the validity and the accuracy of data. All right. So I think my notes also has that. So data collection, design experiments, survey observational studies, automated collection data such as phone data, click-through rates, or stock exchange information, sampling, sampling is taking a subset of the whole population for analysis, and yeah. Right. So in the sampling frame. Let's talk about sampling, since sampling is such a big part, and in the future we're going to be talking about hypothesis testing, and then that's just a derivative of doing sampling and doing type 1, type 2s, for example. So there are many types of sampling. So there are probability sample. Okay, so when choosing a sample, it is important that the sample represents the population. So that's the whole idea, and the whole and where lots of type 1 errors come into play when the sample taken from the population is not an accurate representation of the population. So in order for the sample to be an accurate representation of the population, we have to account for many different errors. Now, there are a few ways in which samples can be chosen. We have a few right here. We have non-probability sampling and probability sampling. Probability sampling is a better representation of the population, whereas non-probability sampling perhaps does not offer the best insight into what the population is like, and the sample may not accurately reflect the entirety of the population. What are some, for example, judgment sampling is when the person conducting the sample chooses people that are participating in a sample. Now, there are some pros. Of course, the pros are that the person conducting the sample perhaps has the most amount of information and knowledge about the sample, and can choose people wisely. Whereas the arguments against judgment sampling will say that, this sample may not be an accurate reflection of the population. Another non-probability sample is self-selection. So the difference between non-probability and probability samples is that probability samples, everyone has the same chance of being selected, basically. Whereas non-probability sample, not everyone has the same chance of being selected from the population to be part of the sample. Self-selection sample is, you could choose to answer this questionnaire, or you could choose not to answer this questionnaire. Now, people, for example, with higher incomes tend to not want to answer questions about their incomes, whereas people with lower incomes tend to answer more questions about their incomes. That makes perfect sense. So this is where self-selection problems will come into play. Another non-probability sample is convenience samples. Convenience samples is, I go on campus, I start sampling people about their views on pineapples on pizzas, for example. Now, are the people on my campus an accurate representation of the general public? Of course not. People on campus are usually younger. People on campus are usually more broke, for lack of a better term. But yeah. So that is not an accurate representation of the population. Whereas simple random will be, I put everyone's name in a hat, and I randomly choose a person's name, choose a few people's name out of the hat. So that would be simple random. Let's go through these. So probability sample, we have simple random, drawing names from the hat or using the random between function of Excel. Systematic will be selecting a random starting point, but then selecting a fixed number of data points that follows. For example, if I want to sample a street, okay, a very, very long street, instead of doing everyone or randomly choosing someone out of the population, I could randomly start with a house. Okay, so I could do a random number generator and come up with the number 4. So I'm going to do 4, 6, 8, 10, 12. So every other house after the 4th one, I'm going to sample them. So that will be systematic. Now, this is systematic is a probability sample because everyone has the same chance of being selected. Cluster sampling is dividing the population into frames or clusters and then doing simple random samplings within these clusters. Now, this is because often minorities may be overlooked in sampling. For example, Asians are minorities in Australia, and then the views on Asians about certain political pollings may be underrepresented because they are not represented properly in the samples. So, cluster sampling ensures that the population is divided into certain clusters. Ethnicity or race, perhaps, and then based on these race, they do a weighted average of a simple random sample, where each of the people within this cluster has an equal chance of being selected. All right. Lastly, we have stratified, which is dividing frames into groups or stratas based on age, gender, country. So it's a little similar to cluster, whereas cluster is just random groups, but stratified is based on some sort of characteristics. Okay, so this is sampling. Organizing, okay, before we go there, we have to talk about some sampling errors. So, of course, we have coverage errors, where some groups are not properly represented or represented to the right ratio within the framework. So that could be minorities, perhaps, and whatnot. Non-response error is the problem a lot of survey type questions will face because people certain groups may have the tendency not to respond to the surveys. And those groups are also valuable data points. So by having non-responses, the data points are skewed. Sampling error, where the population or the sample does not actually represent the population, as well as measurement error, where there is weaknesses in how the question is framed. So for example, if I want to ask, how much money do you spend on plastic bottles every week? And then in parentheses, I say, if $5, say 5. Now, instead of saying 5, I may say instead of 50, in case of 50, say 50, $50. But the difference between 5 and 50 is a framing question, and it could lead to measurement errors or weaknesses in how the questions are framed. Okay, so here are some breakdowns of that. All right. So organizational and visualizing data. Now, of course, we have different charts. This isn't really the most difficult part. We have summary tables, pie bar, Pareto, contingency, side-by-side bars, heat maps, Sankey, ordered by array, frequency distribution, histogram, scattered line, area, for example. We're going to get more used to these principles of good graph making. So, of course, these are some checklists of a good graph, for example. So yes, in general, this is what we have learned. In week one of quantitative business analysis. It is quite a holistic introduction to data, to statistics, to quite a holistic introduction to data, to statistics, and to information, and to analyzing and using statistics in the business context. So yeah, that's what we learned, or what I learned at least, in week one of quantitative business analysis. I hope to see you guys next time, where we'll be getting into some other classes, and week two, week three, more of this. All right, take care and goodbye.